Hello friends, so in this today I'm going to make this video on the marine magnetic compass. And since you know this topic is very vast, it will take a long time to cover all this. So I'll make the video in part by part, and same time, since this video is very vast, we'll not go very detailed in each and everything. So we'll discuss only those things which is required for our exam purpose, as well as which will be required for our understanding purpose. So in this video, will not take much time. We'll not discuss anything more, and we'll directly go to the topic and we'll cover one by one. So first thing what we'll study here is we'll come to know about what is magnetism. Then we'll little bit about earth magnetism, what is earth magnetism, and then ship's magnetism, and then we'll go and study one by one all the coefficients which we'll discuss later. So without delay, we'll just start this magnetism topic. So what is magnetism? First of all, we'll come to know, we'll try to understand this magnetism. What is this? So magnetism in nothing. This is a physical phenomena in which some material like ferromagnetic material which attracts towards a magnet. So we'll discuss about the ferromagnetic material. Ferromagnetic material. Which all the materials are there which is categorized as ferromagnetic. Few of them are like these are iron, cobalt and nickel. So these elements show some magnetic property. So if you keep this metal, these like iron, cobalt and nickel, in the influence of magnet, then it will possess some magnetic behavior. So this may be of two kind, either permanent either permanent behavior, permanent yeah, you can say it can become, it can convert to the permanent magnet or induced magnet. It depends on few factors. When it will become permanent magnet, when it will become induced magnet, it depends on how much it has been influenced with a magnet which is already a magnet. If we'll keep this iron, cobalt or nickel, this ferromagnetic material, in the influence of this any magnet, then it will behave later on, it will start behaving like either permanent magnet or induced magnet. And these things depends on permanent magnet. If you keep iron, suppose we'll talk about the iron and any ferromagnetic material. If you'll keep this material in a particular direction for a long time, and at that position, that material has gone through various, like striking, some heating or any other type of such behavior which is trying to influence its structure. Then what happens actually, the alignment, like suppose this is the iron piece and there are many elements are there. So after, if either you are striking or you are taking a permanent magnet and continuously rotating around it, so what happens, the each and every element inside it gets aligned in a particular direction, in a particular direction. And if it is continuous for a long time, then it will arrange, these elements will arrange permanently in this direction, and thereafter it will behave like a magnet, because their magnet has been arranged in a particular direction, and then it will become like a permanent magnet. And some other type, like if it will come in the induced, if we'll talk about the induced magnet, then what happens, if suppose you have a permanent magnet, like suppose this is north pole and this is south pole, and you are just hanging any, like suppose a pin or something, like a, or a nail type something, or nail type, then what happen, it will show a magnetic behavior, and it will just it will touch one by one on the north pole, and same like suppose this is like suppose this is any material, then it will start sticking like this, and it will pose a pull in this material. Like if it is north pole of this magnet, then here it will come as a south pole, again here north pole. For this one, again here south pole, here north pole. So in this way it will just behave like a magnet, and as soon as you remove this magnet, these all pin will get separated. These all pin will get separated. It will no longer be sticking to each other. Means it is just induced. It is just an influence of this magnet, and it is behaving like a magnet, but it is not a permanent magnet. But in this case, it will become a permanent magnet, and it will act like a magnet. It can induce some other material, so it will become permanent magnet. So we will not discuss much. I think this is more than enough for understanding of this topic. So now, how the things get magnetized, we'll discuss now that point. Like strength of that material, like any object which is going to be induced, the strength of that magnet, strength of that magnet, or of that object, it depends on the strength of ferromagnetic material. Ferromagnetic material depends on two uh, two function, you can say two factors. That's better. Two factors. The first one is the strength of inducing material, inducing, you can say magnet, because it is already magnet, inducing magnet. And second is alignment of that material in magnetic field. So like any object which has been induced, which has become induced magnet, or it be having like induced magnet, it depends on two factors. The first one is strength of inducing magnet, and the second is alignment of that material. Now what is this? We'll discuss that one. So strength of this inducing magnet means, if we are putting any magnet, which we just shown, like suppose this is north, this is south. So any object which is like this one is sticking continuously, like this one, suppose, or the different material which is being stick. So how much strength of this magnet, it depends on this, the strength of this magnet which is inducing this material. So the first thing is this, and second one, like suppose if you are putting, like suppose this is a magnetic field line of magnetic field, like from here it is coming, and it depends on how you are keeping that material which is inducing actually that ferromagnetic material. Either you are putting in this direction, or you are putting in this direction, or you are putting in this direction, somewhat like this. Like suppose this is not completely horizontal, this is 0 degree in reference of this magnetic field. Like suppose this is 45 degree and this is 90 degree. So it depends on this angle also, and it depends according to the sign of the theta. Like suppose if you are putting this one in this direction and your magnetic field is like this, so it means sine 0. So sine 0 is 1. So maximum induction will take place in, if you are putting in this direction. So what we call this, like brought down and end on direction or brought down direction, will just discuss later. And this is 45 degrees though. So according to the, oh sorry, this is not sine here, cos, I just get cos theta. So because cos 1 is cos 0 is 1. So the maximum induction will take place in this direction. So yeah, according to the cos direction, the induction will depends on this ferromagnetic material. So now we'll go and little bit we'll discuss about the magnetic property of the ferromagnetic material. So these all things we'll discuss one by one. Magnetism. So right now we are on magnetism. So first thing, if any object is getting magnetized, like suppose this is a length of a magnet which has got magnetized, and in whole topic we'll not discuss about north pole and south pole, we'll just discuss about red and blue. We'll discuss later why. So like suppose here it is red pole and here it is blue pole, so magnetic field line, it will always uh, exit from red and it will re-enter to the blue, which you have already learned in your academic 11th, 12th and even 10th. So it will come out from the red pole and re-enter to the blue pole. Now the thing is magnetic pole. What is magnetic pole? Magnetic pole is, if you say here this means, we'll say this is the magnetic pole and this is the magnetic pole, like this is red pole and this is blue pole. But where it is actually, it is not exactly at the end or somewhere here, or if you think it is somewhere from this, suppose if you are taking the half part and we say this is the blue pole and this is the red pole. No. So where it actually lies is not exactly at the end or not exactly on the after the middle length. So where it is actually the, suppose total length is L. So it lies somewhere L by 12 on each side. L by 12 on each side. So this is what is L by 12 and this is what is L by 12. Now this is about the pole. So now we'll discuss about what is the magnetic length. So what is the magnetic length? Magnetic length we'll discuss. This is the magnetic length, because actually pole is here, so this will not consider as a length, magnetic length, and this one also will not consider as magnetic length. So I'm just writing with a small l. This is magnetic length. So how much it will become? Since total is l, so l minus l by 12 plus l by 12. So how much it will become? L minus 6 to l by 6, that is become 5l by 6. 5, 6, 5l by 6. So the magnetic length will become 5l by 6. Now we'll not say this one red pole and this one north, or this one as blue in the whole chapter. So what we'll say is this one will become north seeking, pole, and this is south seeking pole. Now before we proceed, we'll just know few more things about this, just terminology. Like suppose this is the magnet, and now since we have already discussed this, I'll just stop it. Okay, so the line, actually if we'll draw some dotted line here, which is going from pole to pole, then this line is just connecting both pole somewhere. So if we draw any line on this passing through this two pole, this line will call as end on. It will be end on position, you can say. And anything perpendicular to this, that will be called as broad on, broad side on, actually say broad side on, and end on or end side on, we can say whatever. So these are the terminology, and these all the lines which are coming out, we can say it magnetic field line. And this length we have already discussed about. So this is called magnetic axis, you can say this one as magnetic axis, this one which is connecting both length. So magnetic length we have already discussed about, this is 5l upon 6, and non-position we have discussed, and then broad on side we have already discussed. Any point perpendicular to this we have already discussed. Now few things like field strength. What is field strength? Field strength means how we have already discussed, no, that how it depends on the how strong the magnet is. So it just we used to if you discuss about the unit, so it's a ampere meter, also denoted by H. And next thing is pole strength. We will talk about pole strength. This is Weber meter. It is also write as small m, or we can denote it by phi. Now magnetic moment, which is where meter, it is written by capital M. So one thing is to know here is the strength. If you'll discuss about the strength on, we'll just compare this what is the relationship between end on position and broad on position, because this is important, and this will be useful. This will be, again we'll talk about this when we'll go to the when we'll study the induced magnetism. That time it will be required. So we'll just keep this point noted, that relation between end on position and broad side on. So it is written like this, because I told this is showing the strength H. So end on position is equals to twice the H broad side on. Means if you are putting any ferromagnetic material in this direction, and suppose this is your magnetic line of force, which is this is the magnetic line of force, and you are putting any ferromagnetic material in this direction, which is passing through the end on position, that time the strength will become twice the broad on position. Like same in the same magnetic field, if you keep it like this direction with the perpendicular to this line, then it will become half of what we have got in end on side position. So this is about the what is it? This is the relationship between this both. So now how it influence, we'll just discuss how it influence the ferromagnetic material, and thereafter we'll not take much time on this topic and we'll go to the earth magnetism. So like suppose I have already talked already about this. This is the ferromagnetic material, this is the ferromagnetic material, this is the ferromagnetic material, and this is the magnetic field in this direction. And this one, you suppose a red pole is here, red pole is here, red pole is here, blue pole, blue pole, and blue pole. This is red pole, red pole, red pole, red pole. So this is 0 degree, this is 45 degree, 90 degree. So it varies as, you know, amount of induction. Induction is directly proportional to cos theta. So here cos 0 is 0, so maximum induction will take place in the direction, this 45. So you know the curve of cos is like this, 0 degree, here suppose 90 degree, here somewhere it is 45 degree. So and this one suppose 1, 2. So the cos, I'm just reminding you, this is the curve of cos theta. So on 0 degree, this is the maximum, and at 45 degree it is reducing, and at 90 it is 0. So if we are putting any material in this direction, that will become this will become there will be no induction in this direction. So this will be helpful later on when we'll talk about the induction, when we'll study about the induction. Now a little bit about magnetic property, which you already know. What is the magnetic property of any material? So magnetic property, what is that? There are two property of magnets. This topic will be magnetic property. Magnetic property. I'll just type. So like magnetic property, there are two property. So two properties, actually this is the basic thing which you already know. The free suspended magnet, if we hang it in the freely, then it will align itself with the magnet, with the magnetic meridian, with the red pole towards the north magnetic pole of the earth and blue pole toward the south magnetic pole of the earth. And that's why wherever we'll study in this topic, we'll not talk about north and south, we'll just talk about red pole and blue pole, and that will be helpful. Otherwise if you go to the north and south, that will be very difficult to understand. And this thing we'll discuss about why we are doing this, why we study this, like only with the blue pole or red pole, we'll discuss when we'll talk about the earth magnetism. So this thing, and the second one is unlike pole magnets, unlike poles are of magnet are attracting each other, and the same like pole repel each other. We know these things. So this is all about the magnetism. Now we'll a little bit study about the earth magnetism, and thereafter we'll go to the ship's magnetism. And there actually this chapter for us, for the marine magnetic compass, it will start there, when we'll start a study about ship's magnetism, because that is the important thing, what we have studied or what is going to be asked in our exams. So now we'll discuss about earth magnetism. So now this is earth magnetism. So we'll just discuss about little bit thing about the earth magnetism, and then subsequently we'll proceed for the ship's magnetism. So first thing we'll come to discuss here is about what is earth magnetism. What is the geographical pole, what is the north magnetic pole, south magnetic pole, and events. So actually it is a suppose this is a earth. If this is a earth, this actually I'm showing here a magnet, but it is not exactly a magnet here. And how the earth behaves like a magnet, you must have studied this one in your academy. If not, then you can just take help of any, I know, Google or somewhere, how it actually it is not required for our syllabus, but just if you are more curious about that, then you can check how it behave like a magnet, how earth behave like a magnet. The many things, actually if you go inside the earth, there are many uh, materials are there which is continuously rotating. So after rotating, its electrons are moving, and thereafter lots of processes will happen there, and then earth is behave like a magnet. You can just search on the Google or somewhere, you can find out. But it is, I'm not discussing this all, because if we go to that topic, then this earth magnetism. Magnetic compass is already a very long topic, so it will take much time. So it is just here for our purpose, it is just an imaginary magnet. We assume that imaginary magnet is present inside the core, in the core of the earth, which is uh, which behave like this, like suppose it is a behave like a magnet, like a rod. A magnetic rod is placed uh, which is passing through the earth equator, like this one, this blue line. I'm just showing it here as a equator, earth magnetic equator, and not magnetic equator, it's the earth equator. And this red one is magnetic equator, magnetic equator. So what happens, the earth magnetic pole is not exactly what is the geographical pole. What is the geographical pole? Geographical pole is one, it is an axis, like earth is rotating about its axis, so that axis is, just assume it is passing through the earth surface somewhere, and it is cutting the earth surface somewhere. So wherever it is cutting the earth surface, that position is called as north geographical pole and south geographical pole. And this is exactly symmetrical, means exactly in the same line. Like if it is coming out from here, then this line will be exactly straight, our earth rotation. But the magnetic pole are not symmetric, not symmetric, because maybe north magnetic pole is somewhere here, and south magnetic pole is somewhere here. It depends on various things we'll discuss, and this is the that will be one question for our exam also. So we'll discuss on which all factors depend on this magnetic north pole and south pole. For now, we'll just discuss the, suppose this is our earth is behave like a magnet, and we are assuming that one big, very big iron rod or a magnet is placed inside the earth core, which is showing the blue pole at the north side and on red pole on south side. And wherever it cutting the earth surface, this one is known as north magnetic pole, and wherever it is cutting the south side, it will be called as south magnetic pole. You can see here the blue dotted line is the earth equator, and this red line is showing magnetic equator. So the point here to note down is, if you see here, the blue dotted line means earth equator is exactly 90 degree from this geographical pole, but the magnetic equator is not exactly the 90 degree from this pole, because it varies, because magnetic pole is not opposite to each other. Yeah, since it is not exactly opposite to each other, that's why it is not a straight line, and it is somewhere curved, somewhere it is lower, maximum lower on the south side, and somewhere it is maximum on the north side. So it depends on the where the earth magnetism is much. It depends on various factors, we'll just discuss later. So this is about this little bit of terminology. Now a few things more. See, here I am showing the same thing, same picture I have taken there, and we'll discuss something more here. So now consider this earth magnet is in the earth core, and it is showing a green on the north side and red on the blue side. Just here only I will clear a doubt that why, in academic, in our academy, because here we'll discuss about only green pole and this blue pole and this red pole, no north and south, because few students get confused that when we are hanging some a magnet, then red pole is attracting towards the north, and whatever we are considering, that red is on the north and blue is on the south. So why? Because in the earth core, the magnet which has been placed, actually not placed, but which we are considering that it has been placed in the earth center, earth core, which is blue on the north side and red on the south side. And we know that magnetic line force is coming out from the red and re-entering to the blue. That's why, since earth is showing blue on the north and red on the south, that's why whenever we are hanging any free magnet, then red pole, because red and blue is alike, and so it will attract. That's why red pole is attracting towards the north, and that's why we are showing that wherever our compass or something is there, which is showing, wherever red is showing, that we consider as north. Because if we'll hang a magnet somewhere on the earth, then suppose this is north, and this is north side, and this is south side, so it will align itself in this direction, because red will attracted by the blue of the earth, and blue of magnet will attracted by the red of earth. So hereafter we'll not discuss about the north and south, we'll just discuss about the north and red and blue. And here only you just mark this point, that in earth it is blue on the north side and red on the south side. That's why wherever we'll discuss about the Earth's magnetism or anything, will every time will show that red will be on the north side. Red will attract on the north side because it is blue in the earth core. Blue pole is in earth core. So red will be on the north and blue on the south. Anyway, later also we'll discuss wherever there will be discussion, we'll discuss that time also. Now the next thing we'll discuss, the most important here is deep. What understand about deep? So I'll just write earlier and then we'll discuss. So the next topic is deep. So what is, actually it is the important topic. So what is deep? So deep is the I've already written here, so you can copy from here. The angle between the earth magnetic field line. So what is the earth magnetic field line? All the line which I'm showing, which is coming out from this red pole and re-entering into the blue pole. All these line are magnetic field line, and the horizontal plane at a specific any place this line is making with the horizontal, whatever the angle is making with the horizontal, that is the deep of that particular location. So in other word, to just to understand, we can also understand by this, like suppose we are hanging a freely we are freely suspending a magnet at any location, and that suspended magnetic needle make with the angle which it made with the horizontal when held in a vertical plane aligned with the magnetic field. So all the magnetic fields are there. If we are hanging any, like I have shown it at various location at equator, at north pole and south pole, and one at intermediate position between equator and this north pole. So how it will behave, it depends on, like suppose here the magnetic field line this magnetic field line are like this. It is coming out from here and re-entering into the blue line. So if we are hanging a needle here, it is exactly parallel to this line. If I proceed this line, if I continue make this line, so this line magnetic field line and this our suspended needle is exactly parallel to each other. So it is making a 0 degree angle with this magnetic field line. So and with the what is that plane of that what is that, this horizontal plane of the magnetic field. So it is making a 0 degree angle at equator. So this needle is completely horizontal to the plane. And here I will talk later on what is H and what is Z. This is H is denoting the horizontal component of Earth magnetic field. This earth magnetic field are there, so it is completely parallel to this. That's why it's making a 0 angle at this point. And if you see here, I have shown here the red point on the north side and blue on the south side. So if you hang, the red part of that needle will lying on the north side, because in the earth core it is blue on this side and red on this side. So the red point the red end will be on the north side, and when we are at equator, once we'll go a little bit on the intermediate part between the equator and pole. So you can see this is the red pole and this is the blue pole. It is just away from the center, but at this position it is not, this needle will not be exactly horizontal to the surface. It will also dip towards the into the earth, and that's why we said it is not only, because when we are at equator it is only one component, that is the horizontal. Because if you hang something, it will be lying parallel to the earth surface, completely parallel to the earth surface, and there will be no any dip or something like this, no any tilting or something. So it will remain horizontal. So there will be only one component, that is H. H is the horizontal component of earth magnetic field, and Z is denoted Z denotes the vertical component of earth magnetic. So this needle when will bring in any intermediate position after the equator, so it will show horizontal component also, and it will dip towards the north and will dip towards the earth center into the earth. It seems like it is going into the earth. So that time there will be some Z also, means vertical component also will be there. So horizontal and vertical component will also be there. And the same needle if you bring here, it will, there will be no any horizontal. If you hang this suspended needle, it will go exactly, it will show in this direction, like it is going, the one end will going into the earth surface and the other one is going outside, means the red end will show going into the surface. So at this time the needle will not behave like horizontal, it will not align in the horizontal manner. It will show in the exactly like this vertical. So only one component will be there, that is Z. So these are the way how we denote the dip. like how we split this both vector, like horizontal and vertical. So this is the H, like horizontal component, which is like this, and the Z, which is going either into the earth surface or away from the earth surface, that is denoted by Z, which is vertical component of earth magnetic field. So here, and this is the resultant. So here we can write it, here the same thing we can write. I will just rub this tan dip, is equals to Z upon H. We can write like this, and H also we can write like T cos dip. We can write like, if we rotate this component, so H will become T cos, T of cos dip, this theta is dip. So we can write it like this also. And the same way, if we write for the Z, then we can write T sine. You know how to split the component dip. So in this way we can write T equals to root under H square plus Z square. I hope you know this, how to do this. And for the sign conversion, yeah, one more important thing is sign convention. Sign convention. So H is always towards magnetic north. Take positive. Okay? Positive. If it is magnetic north, if it is north H, then we'll take it as positive. And if it is south, then we'll take negative. Same way for Z, positive in northern hemisphere, negative in southern hemisphere. And now this needle, when we placed at equator, it is horizontal and only one component is H. When we are placing it at pole, it is making 90-degree angle, and that's why cos 90 is 0. So there is no H, only Z component will be there, and red will point towards into the earth, towards the earth center. And same thing, if we bring at the south pole, then the blue pole will so towards the center and red away from the center of earth. So this is the behavior of the needle when we are hanging, and this is also in other way, it is showing the deep at a particular location. So I'll just make a table which will explain how the needle will behave, how the deep will change at various locations, either at equator or at pole. Yeah. So how it behaves when we go at the equator. So I've already discussed in the previous figure. H is maximum at the equator because it is aligned with the magnetic line of force. So it is maximum here, and there is no Z. Z is nil at the equator because it is neither going towards the center now away from the center of the earth. So it is 0, and therefore dip is also 0 at the equator. At north pole, H will become nil because there that time it is no more horizontal component is there. Only deep means the needle will totally so towards either towards the center of the earth or away from the earth. So in the north pole, it is the red pole will show towards the center of the earth. So H will be, there is no any horizontal component. So H which is horizontal component is nil, and Z which is vertical component, that is maximum because it is showing totally towards the center of the earth. So that's why Z is maximum, and deep is 90-degree plus, because I have shown already how we have to show the sign conversion I have shown. So deep will be plus 90. At the same time, the same thing will be there, only deep will be minus 90. Apart from this, what we have to know is the magnetic element, what all the magnetic elements are there. That is the last topic for this earth magnetism. So we have to know about the magnetic elements. So there are three elements. The first one is total field strength, total field strength, which is Z and H, either vertical or horizontal. Second one is variation, which we know what is variation. And third one is dip, which we have already discussed. So these three elements are there for this magnetism, earth magnetism. Apart from this, what we have to learn is secular changes, what is secular changes and what is transient change. We know now that how the earth magnetic behave actually. So what is secular change and what is transient change? So the two thing is, first one is secular change, and second one is transient change. Transient change. So we'll see one by one what is the secular change and what is transient change. Secular change is actually, what is the change is, because these changes happen because the magnetic pole of the earth, which we have already shown, that geographical pole, which is a fixed point, and uh, which remains fixed around sorry, about which the earth spin, and the magnetic pole is somewhat different and which keep on changing. So that is what the secular change actually. It is because the magnetic poles are slowly shifting around the geographical pole, and that is because, and that is the reason of this secular change. And what is transient change? We'll see 5-6 points are there, which we just need to remember for your oral purpose only, because I haven't seen ever it has been asked in any written exam. So that there are only 6 points, we just have to keep it remember for our oral, and that's all. So just go for this to secular change and transient change. Thank you. So this is secular change and transient change. In secular change, you can see it is because of magnetic pole are slowly shifting around the geographical pole, which we have already discussed. That geographical pole is somewhere, that is a fixed point, and magnetic pole is changing. That is slowly shifting around the geographical pole. So this is about secular change. And transient changes, there are few 6 points which you just keep it remember, that may be asked by the surveyor during your exam or during your oral. But so far now I haven't seen ever this question as asked in our written exam. But just for your oral purpose, you can keep this remember. So it is because of daily change due to sun, twice daily change due to moon, and yearly change it happened because of this earth's orbit around the sun, and 27-day change due to sun's rotation about its own axis. One is the 11-year change, that is sun spot activity, and the most pronounced, this is local magnetic storm. This is the one which affects maximum, this local magnetic storm. So this is all about this earth magnetism. And thereafter, after this video, we'll start with the ship's magnetism. That is the actually our topic will start from there, and that is most important. So thereafter we'll start for this topic. This is all about. Thank you. We'll meet in next part. Thank you.